In this video we have integral number 5 in this particular series. The last one we did involved integration by parts. I used the abbreviated form, or the DI method, tabular method, different names. And that one, the last one was the one where it repeated. So we had to take the integral on the right and bring it over to the left and then divide through by the coefficient. Or I'll put a link to that video in the description in case you didn't see it. In this case we have one term is x to the fourth, the other one is e to the 3x. E to the 3x is easy to find the derivative or differentiate or integrate. X to the fourth, no problem. But what we want to do, of course we have one column for the derivative, one column for the integral. So on the derivative column we're going to put x to the fourth, and then we're just going to differentiate. So the derivative of that is 4x to the third, and we keep going, and it's 12 x squared, and then it's 24x, and then it's another derivative is 24, and then it goes to 0. So we actually stop right there. On the left side, I'm going to tell you the right side, I put e to the 3x, and we just integrate. Integral of e to the 3x is e to the 3x, and we have to put a 1/3 here because we take the derivative of 3x, we get 3 and divide the coefficient, and then we keep going. It's going to be e to 3x, e to 3x, and so on. All we'll be doing is multiplying by a factor of 1/3 because of this exponent here. So if we continue that procedure, this is what you have. So the x to the fourth would be your u in the standard procedure. The e to the 3x would be the dv, and this would involve integration by parts repeated several times, so it'll be lengthy. But with this method, it really shortens it, because all we do is, again, take the u on the right side, and left side rather, take the derivative, and if it goes to 0, that's even better. This one did. And then on the right, we take the integral and keep going. And then we have to remember that the signs will alternate. And this comes again from the procedure. If you look at your formula, you have the product of u and v, and then it's minus the integral. And this is a case where it's going to repeat. So it keeps on going plus, minus, plus, minus, plus, minus. And then all we're going to do then is multiply diagonally this way. X to the fourth times 1/3 e to the 3x, and then on this one, take the sign with you, minus 4x to the third times the 1/9 e to the 3x, and then the plus 12 x squared, multiply that way, and then minus 24x times that term, and then plus 24 times 1 over 243 e to the 3x. Reduce it here, you can reduce those. And then you stop here, because from then on it's just going to be a 0. So if I multiply, remember, anytime you multiply the components of a row, that's an integral. So if I say 0 times this term here, that's 0. But the integral of 0 is a constant. So that's why we can stop there. So if you do that procedure there, or multiply diagonally, write out your terms, this is what you wind up with. Those are the terms you wind up with. And I did reduce those on the product there. They're reduced. So the first term is 1/3 x to the fourth e to the 3x minus 4/9 x to the third e to the 3x plus 4/9 x squared e to the 3x, and so on. You can see the terms there. Constant of integration. Thanks for watching. We'll see you next time.